Lesson number 9, Two-Way ANOVA. Two-way analysis of variance. Why we call this two-way? Let's define two-way ANOVA. Two-way ANOVA compares the mean difference between groups that have split on two independent variables called factors. We call this two-way ANOVA because we have two independent variables and each variable has categories. Then you will compare this to our dependent variable, only one dependent variable. The primary purpose of this test is to understand if there is an interaction between the two independent variables on the dependent variable. 2 IVs to 1 DV. For example, you could use a two-way ANOVA to understand whether there is an interaction between gender and educational level on test anxiety amongst university students. Where gender, males or females, and education level, undergraduate, postgraduate, are your independent variables and test anxiety is your dependent variable. That's very clear. Next. The interaction term in a two-way ANOVA informs you whether the effect of one of your independent variables on the dependent variable is the same for all values of your other independent variable and vice versa. Let's say, for example, in here, you want to know the effect between the effect of gender to test anxiety. So, it will become significant if also educational level has effect to test anxiety. But, if only one has effect, it is still, overall, it has significant effect. Kahit isa lang yung may effect, as a whole, may effect pa rin. The interaction term in a two-way ANOVA informs you whether the effect of one of your independent variables on the dependent variable is the same for all the values of your other independent variable and vice versa. For example, in the effect of gender, male, female on test anxiety influenced by educational level, undergraduate, postgraduate. Additionally, if a statistically significant interaction is found, you need to determine whether there are any simple main effects and if there are, what these effects are. How to perform, how to know if you will use two-way ANOVA in your study. We need to consider the 6 assumptions that you can see. Number 1, your dependent variable should be measured at the continuous level. Still the same. It's continuous, either interval or ratio data. Interval, exam scores, all scores that it doesn't have 0 starting point or no 0 exists. When we say ratio, absolute 0 exists. Assumption 2, your two independent variables should each consist of 2 or more categorical independent groups. So, 2 or more categories. Number 3, you should have independence of observations, which means that there is no relationship. You're just getting the comparison between variables, not getting the relationship. You're just comparing them. Then, assumption 4, there should be no significant outlier. So, no extreme points, no very low points, no very high points like that. Assumption 5, your dependent variable should be approximately normally distributed for each combination of the groups of the two independent variable. So, equally distributed from the mean. Okay, assumption 6, there needs to be homogeneity of variances for each combination of the groups of the two independent variables. So, the more the value, if you get a lower value for standard deviation or variance, it means that your data is more homogeneous, more close to each other, the data scores or the values. But if you get a higher value for the standard deviation or variance, it means that the data scores are more spread from the center, which is the mean. Example. A researcher was interested in whether an individual's interest in politics was influenced by their level of education and gender. So it means we have here our dependent variable, interest in politics. Our DV, when we say IV naman, independent, sila yung makaka-apekto, sila yung makaka-impluwensya, sila yung may impact. Basta impact, influence, more likely effect, at merong interaction, ang gagamitin laging test ay two-way ANOVA. At lalo na pag meron kang dalawang more than one independent variable. So, ang ating independent variables, IVs, level of education, and gender. They recruited a random sample of participants to their study and asked them about their interest in politics. Kumuha ka, nag-gather ka ng sample data, hindi naman binanggit kung ilan, tapos, pinarate sa kanila kung gaano ka taas yung degree of level of interest in politics nila, wherein, it's from 0 to 100, with the higher scores indicating a greater interest in politics. So, sa 0 to 100, the more that your score is getting near to 100, so the more you're interested in politics. But when it's lower than 100, or the more mas mababa sa 100, the more that the interest is decreasing when it comes to politics. The researcher then divided the participant by gender. So, we have 2 categories, and then by the educational level, we have 3 categories if you just turned high school, college, or university. Therefore, the DV was interest in politics, and the 2 IVs were gender and education. How to perform this in SPSS? First, we need to separate the individuals into their appropriate groups by using 2 columns representing the 2 independent variables and label them gender and educational level. So, at first, you need to set up your variable in the variable view. Dun pa lang sa variable view, set mo na yung gender, and then sa gender, punta ka ng values. Diba? Meron tayong first column dun, mga nakahilera, name, type, then values. Iset mo na 1 yung male, 2 yung female. Tapos, dun sa educational level, iset mo na 1 yung school, 2 yung college, 3 yung university. Then, the participants' interest in politics, the DV, was entered under the variable name. Anything will do. Kung ano man yung gusto nyo ipangalan dun sa variable view. So, as you notice, we have here the 2 independent variables, gender and educational level. So, nakalagay dito, male, female. So, words, pwede rin siyang iset ng numbers. You will just click it in the variable view. Then, our values for our DV, which is a continuous variable o data scores. Ayan, kitang-kita nyo, our DV. So, we have here 3 variables. Then, afterwards, procedure in SPSS to perform TwoWay ANOVA. First, click Analyze. Then, click General Linear Model. Then, click Univariate. As you proceed, this box will appear. This dialog box. In our dialog box, you can see at the left side, our variables, which are gender, educational level, interest in politics. Then, input the interest in politics in our DV, dependent variable, in our next dialog box at the right side. Then, you will input the IVs or independent variables in our fixed factors, and the rest, leave it blank. And as you notice, at the right-hand side of our dialog box, you can see different options, which are model, contrast, plots, post-hoc, save options. What you're going to use in these options are just plots, post-hoc, and options. Then, so as you click this plot option, this will appear. Okay, so what are you going to do as you click plot? You will input any independent variable. Pwede sila magkapalit ng pwesto, I-input mo lang sila dun sa horizontal axis saka dun sa separate lines na mga options or boxes. So, yung gender, ang ginawa, in-input siya sa separate lines. And then, yung educational level, siya yung nasa horizontal lines. Although, you can interchange them. Next, click nyo yung add. Nakikita nyo ba yung word na add dito nakalagay sa baba, dun sa plot? So, pag in-add nyo sila, mag-a-appear sila sa baba. Ito. Nag-appear siya dito. Educational level, gender. Nagkaroon ng asterisk. Pinagsama na sila. Then, click continue. Then, click again another button, option, post-hoc. As I told you, it can be found here. Ayun, no, nakalagay. Kasunod ng plus post hoc. Ano bang purpose ulit ng post hoc? Ang post hoc, ginagamit mo para malaman mo yung individual comparison ng one variable to another variable. Hindi as a whole. One by one. So, as you click this post hoc, this box will appear. So, in this box, you need to input educational level doon sa ating kanang bahagi. One independent variable muna. Then, click the Taki method kasi yung Taki method ang ginagamit para makuha mo individual effect or you can compare. Click continue. Then, return to the univariate dialog box. Babalik ka dun sa original box na mag-a-appear pag kinlik mo yung univariate. Then, click their options button. This will present this box. Ita-transfer mo yung gender, educational level, and gender times educ level from the factors and factor interaction. So, nagkaroon ka na ng options dito. Okay? So, ang gagawin nyo kasunod, input nyo silang tatlo dun sa kanang bahagi. So, na-input nyo yung gender, educational level, gender times educational level. Then, ipe-present natin naman yung descriptive statistics. Bakit kailangan i-present? Para ma-compare natin yung means sa standard deviation. As you're through, click continue, then click OK. These outputs will appear. First, we have here the descriptive table result, wherein we have there the gender, comparing the gender in terms of their educational level. Example, male here. We compare male from school, from college, from university. In terms of the gender male, so when it comes to interest in politics, who are the more interested? Those male that came from the university with 64.10 mean. So, as you notice, this one is the highest. Okay? Then, followed by from college. Male from college, they are interested in politics. And lowest, the least, is they came from school, 38. Siguro, kaya ganon, when it comes to gender, the more ka kasi nagmamature, the more na nagiging aware ka sa paligid mo. Kasi pag ikaw ay nasa school pa lang, let's say for example, high school lang yan, so mas less yung interest nila sa politics. So the more you're getting older, or you're growing, getting matured, so the more you're interested in politics. Kaya mas marami interested sa university. When it comes to female, still, we have the same sequence. It gets higher and higher the more you turn into higher education. Diba? From school, high school, let's say for example, 39.6 yung kanyang mean, college, 44.6, tapos university, ayan ang highest. Okay? In terms of gender male and from the free educational level, we may say that the data, the scores are more compressed or more closed from the university. Diba? Nakita nyo yung standard deviation, mas mababa yung value dito sa taas, 3.07. Ano yung mas scattered, more spread from the mean? Ito. Yung college, kumbaga mas iba-iba yung kanilang interest in politics, magkakalayo yung kanilang scores. So, in female, the higher variation or higher standard deviation is the university. So, with the standard deviation of 6.46. Okay? So, more spread yung sa university. So, in terms of the level of educational attainment, mas malaki talaga yung mean pag galing sa university. Combined na yan in total. Next. We have another table showing the p-values, the effect of the independent variables to our dependent variables. So, kung makikita nyo, dito lang kayo titingin sa naka-highlight ng red. When it comes to gender, may interest ba sila sa politics? Kung makikita niya, ang kanya naging p-value, 0.207, no. So, it means there is no statistical significant effect of gender to interest politics. So, hindi nakaka-apekto or walang interaction yung gender sa politics, interest in politics. So, it doesn't matter. Male or female ka, both gender, parehas mas mataas yung university. So, walang pinagkaiba. Kaya, nakita niyo, mataas yung fee value. Greater than 0.05. When it comes to educational level, ayan, there is a statistically significant difference among the educational level of our participants. May pinagkaiba. At as a whole, pinagsama mo yung gender sa educational level, may effect. Kasi nagkaroon ng effect yung educational level eh. May difference. It means, as a whole, may difference. How to interpret these two tables? These rows inform us whether our independent variables, the gender and educational level rows, and their interaction to gender and educational level row have a statistically significant effect on the dependent variable interest in politics. Ito yun. Yung naka-highlight ng red, yan yung sinasabi ko. Yun yung pinag-uusapan. It is important to first look at the gender and educational level interaction. Pag sinabing asterisk, ibig sabihin nun times. Pag sinabing times, ang English word na katumbas ay N. Pag or, narinig nyo yung salitang or, ibig sabihin nun plus. So, gender and educational level interaction as this will determine how you can interpret your results. So, eto na. You can see from the p-value column or sig column that we have a statistically significant interaction at the p-value which is equal to 0.014 level. So, tingnan natin dito. Ayan. Yung dalawa, pag pinagsama mo sila, 0.014 yung kanilang p-value. So, may effect. Okay? So, may interaction, significant interaction. You may also wish to report the results of gender alone and educational level alone, but again, this need to be interpreted in the context of the interaction results. We can see from the table above that there was no statistically significant difference in mean interest in politics between males and females with a p-value of 0.207. In terms of gender, nakikita nyo, walang interaction yung gender sa interest in politics. Pero yung educational level, statistically significant differences between educational levels because p-value is less than 0.05. Ay nakalagay kasi dito, 0.00. Kita nyo naman, last column. Next. Another output table that you may see as you perform TwoWay ANOVA in SPSS is this Taki table wherein you're getting the individual interaction or significant difference individually. Okay? In terms of educational level only. Bakit educational level lang po, ma'am, yung tines? Hindi po sinama yung gender. Kasi po, napag-alaman natin na educational level lang naman yung may interaction. Kasi yung gender, wala. So, ay test mo lang, kukunin mo lang yung table ng educational level. Okay? You can see from the table above that there is some repetition of the results. Now, ulit-ulit. Okay? But regardless of which row we choose to read from, we are interested in the differences between school and college, school and university, and college and university. From the results, you can see that there is a statistically significant difference between all three different educational level because they are all less than 0.005. So, kung makikita nyo naging resulta, ayan, lahat less than 0.05. So, lahat sila, pag kinompare mo yung school sa college, yung interest in politics, magkaiba. Kasi ang p-value ay 0.00. Pag kinompare mo na may school sa university, magkaiba rin, 0.00. Pag kinompare mo yung, ano pa ba, school, college, school, university, paulit-ulit lang. So, ito lang, dito ka lang mag-focus sa first row. So, as a whole, meron silang individual interaction. May significant difference in terms of educational levels only. So, a two-way ANOVA was conducted that examined the effect of gender and educational level on interest in politics. There was a statistically significant interaction between the effects of gender and educational level and yung may asterisk on interest in politics because we got p-value of 0.040. So, as a whole, meron silang significant interaction or effect. Ayan lang ang ating naging sagot.